When solving a system of nonlinear equations by elimination method, you need to do the following. First, choose which variable you want to eliminate. Second, multiply both sides of one or both equations by a non-zero constant so that the coefficients of the variable that you chose are additive inverses, meaning one's positive and one's negative, and when you add them together they cancel out. Next, add the like terms from the two equations together so that the chosen variable is eliminated. Next, solve the resulting equation for the remaining unknown, and then finally substitute the value, or in this case values, of the variable from step 4 into one of the original equations to get the remaining variable. It doesn't matter which equation, choose the one you think is easiest. So we're going to follow the same steps that we do for elimination method for systems of linear equations for nonlinear. So I look at this and really I have only one option. I can only eliminate the x squareds because I can't eliminate the y squared and y because they're not like terms. So I'm going to take the second equation and I'm going to multiply it by a negative 1. So x squared minus y equals 7. So I'm going to multiply this here, the bottom one, by a negative 1. So when I do that, I keep the original first equation the same, x squared plus y squared equals 13, but my bottom equation becomes negative x squared plus y equals negative 7. Now I'm going to add and cancel, so the x squareds eliminate, they're gone. Y squared and y do not add together, so I'm just going to get a y squared plus y. And then 13 minus 7 is going to give me 6. Now I have a quadratic. I'm just going to solve this, so I'm going to subtract the 6 over. So I'm going to get y squared plus y minus 6 equals 0. And then I'm going to solve this by factoring. And I'm going to get a y plus 3 and a y minus 2. And I solve both of these, I'm going to end up getting y equals negative 3 and y equals positive 2. So that's what y equals, but now I need to know what x is, because a system of nonlinear equations have ordered pair solutions. So I'm going to take negative 3 and plug it back into either one of these. Probably going to do the second one, I think it's a little bit easier. So I'm going to get x squared minus negative 3 equals 7. And x squared plus 3 equals 7. Subtract the 3 over. X squared equals 4. And then finally, square root of both sides, x equals plus or minus 2. So what does that actually mean? It means that x is a positive 2 and a negative 2 when y is negative 3. So I'm going to have two solutions, a positive 2 and a negative 3, and a negative 2 and a negative 3. So here are two of the solutions. But I got to do it again for positive 2. So I'm going to plug 2 in as well. So I'm going to get x squared minus 2 equals 7. Add the 2 over. X squared equals 9. And then square root both sides. X equals plus or minus 3. So just like before, I'm going to have two ordered pairs. One is going to be 3, 2. And the other is going to be negative 3, 2. So I actually have 4 solutions to this nonlinear system of 2, negative 3, negative 2, negative 3, and 3, 2, and negative 3, 2.